Good evening and welcome to UCSD Conversations. I'm Mary Walshock, Associate Vice Chancellor for Public Programs at the University of California, San Diego. It is my pleasure to introduce you to some of our faculty and their cutting-edge research. Please join us for an enlightening evening of conversation. Tonight we'll learn about the search for evidence of life on Mars and meet the new director of UCSD CONNECT, Fred Cutler. But first, Muir College Provost Patrick Ledden, in conversation with Dr. Edward Holmes, UCSD's new Vice Chancellor for Health Sciences and Dean of the School of Medicine. Pat?
Thank you, Mary. My guest today is Dr. Edward Holmes, who is Dean of the UCSD School of Medicine and also Vice Chancellor for Health Sciences. A distinguished medical scientist, Dr. Holmes, before he joined our faculty in September of 2000, was on the faculties of Stanford and Duke Schools of Medicine. Ed, thank you for being here.
Thank you for having me, Pat.
I think being Dean of a School of Medicine, particularly a big and complex one like we have here at UCSD, has to be one of the most challenging jobs around, at least in the university. But I have to feel also right where we are in science and medicine today, it also has to be one of the most exciting.
I would agree with you. You know, we joke and say that big challenges come with big opportunities.
I think you get both.
You do, and medicine is probably, well, I'm biased, but I think
I hope so.
Yeah, it's a terribly exciting time for us in medicine right now. So much is happening. The ability to do things for patients that we never could in the past. That when I got into business about 25 years ago, the drugs that you had available were so limited, the things that you could do were so limited. And now there's just an extraordinary amount that we can do for patients, and it's a very exciting time to be in this profession.
And it's moving rapidly.
Unbelievably. I think that the physicists and the mathematicians and the chemists own the last century, and the biologists
Yes,
and the medicine people may own the 21st century, that a lot of the fundamental discoveries that all of you have made
are leading to.
Yeah, it put us in a great position,
absolutely.
I think, going
Couldn't
forward.
have happened without the basic science that took place from,
Absolutely.
From Newton on. Could not have happened.
You're absolutely
But
right.
now that the instrumentation, all of that, is making just an incredible array of things available to us. Yeah.
You know, molecular biology, for example, is something that seemed like a very esoteric discipline in the past. Now you pick up something like the New England Journal of Medicine, and it's replete with this. It's the way we go about taking care of people now and the way we educate.
Now, at UCSD, the excitement is not simply these things, which I'd like to get back to, but also we're doing a lot of building. A lot is going on, actually, physically on the campus. Is that true?
Well, on the entire campus, as you know, and I'm sure
course.
you've talked with others, that the expansion at the undergraduate level is going to be extraordinary. But the health sciences are fortunate to participate in this.
Yes.
We will, over the next, I think, 5 years, see a number of new buildings go up, which I'd love to tell you a little bit about.
Absolutely.
And I think will have a major impact not only on our school, but on this community, and we hope the health of the community as well. That, for example, we have a new biomedical research building, which we're just getting ready to break ground on in the very near future.
This is the so-called Garamendi building?
The Garamendi building.
Mm-hmm.
And it will be, I think, extremely important for this institution in lots of ways. Number one is we're also recruiting a number of new leaders. We're looking for a chair of the Department of Medicine, chair of the Department of Radiology right at the moment. Other chairs will be coming available in the future as people move on to do other things. And the Howard Hughes Medical Institute, which is a wonderful organization, sponsors some of the very best biomedical investigators, has a strong presence here. We'll get to grow with this new building. We have the Ludwig Cancer Research Institute, which has just been designated for a very substantial expansion under Webb Cavanaugh's leadership. So with the Garamendi building coming on board, then it allows the Hughes Group, the the Ludwig Cancer Research Institute, our departments of medicine probably. And you may recall that back during the summer, UCSD was designated for a very special grant from the NIEHS around the Superfund.
Yes. Right.
Combined effort of the Scripps Institution of Oceanography and the School of Medicine.
Nice collaboration there, yes.
Wonderful collaboration, and we'll be the focal point of a very major initiative that has to do with the environment and health.
Toxic cleanup.
Toxic cleanup,
yeah,
exactly.
Right. What's toxic and how do we get rid of it and so on.
And this Garamendi building presents an opportunity to see these programs grow because we needed the space to do this.
Great.
So that, that's going to be, I think, really important to our future.
Right in the center of the medical campus, too.
Right.
Yep.
The only downside is it takes parking spaces. Which,
that's a serious problem.
It is. You ask the faculty, which would you rather have, benches or parking spaces? And they usually say benches.
They say, let me think about it.
They usually say benches. The addition to our Cancer Center, with the very generous gift of Rebecca and John Moores to name this the founding gift, is going to be an extraordinary opportunity for UCSD and the larger community for cancer-related programs.
That'll be over near the Thornton Hospital.
Near the Thornton Hospital. Will be a building which encompasses ambulatory patient care, will have a very strong preventive medicine program in it, and will also have wet bench and dry bench research related to cancer, focused more at a translational level. So we have the Ludwig Basic Cancer Research Initiative, and we have the Cancer Center, which combined together allow us to go from the most fundamental science.
Bench science, the basic stuff.
Right.
Yep.
We like to say bench to bedside.
Right, right.
And translating this into new discoveries.
Yes.
But
contiguity is important.
It is.
I mean, to have the clinical and the basic science near each other, it matters.
It does in interesting ways. I think our challenge in all the programs we're trying to do here and at other universities is the future is multidisciplinary. We talked a moment ago for the importance of basic science and
physics and chemistry leading up to, yes.
Right, and I think the places that are going to be extraordinarily successful going forward are those that are able to bring together these people from different disciplines. That's where the major breakthroughs take place, is at that interface.
No yep.
UCSD has a tradition of doing that.
Yes, It goes back to the Bonner Plan, actually.
It does. I'm a newcomer, but I'm understanding the absolute wisdom of this institution. We only have 2 basic science departments in the School of Medicine.
Right.
And that forces us, if you will, to have much stronger ties with our colleagues across campus. Right. I think if you take cancer as an example, that's one where we'll have clinicians and basic sciences next to each other, but equally important, making those connections to the Ludwig, to the biologists, to the people over at the Scripps Institution, Oceanography, to bioengineering is really where a lot of the action's going to be. But we feel very fortunate in that we have an NCI, a National Cancer Institute designated cancer center here. And that serves as a focal point through that core grant to allow us to do this basic and applied research and the clinical care that we need to do through clinical trials. And UCSD is really a leader in cancer biology, cancer research, and patient care. And that's a big part of our future, I think. And then another program that I think it's important that I feel unbelievably fortunate to be here and be a part of is that we were designated over the past summer by the Regents to be the home for a new School of Pharmacy.
Yes.
And as Palmer Taylor, who's our chair of pharmacology, likes to kid me, I'll be the first Vice Chancellor for Health Sciences legitimately in which the S at the end of the word has meanings.
It's plural.
Because there'll be now a School of Pharmacy as well as a School of Medicine and the Health Sciences. And it's quite exciting to think about a whole new school, to be the second one in the UC system. Right. And because we're starting from scratch, we have the freedom of a blank slate as to how we want this to go. How should it be done?
Yes.
And so, tremendous amount of excitement in using this as a vehicle really to get into this area of pharmacogenomics that, as you're aware, sequencing the human genome has just been completed, at least in part, in the last year.
Partly by a UCSD graduate.
I know that, Dr.
Great
Ventnor.
Ventnor, absolutely. Graduate of my college, in fact.
Is that right?
Yeah, right, the undergraduate.
And he's a very important alum who
right.
It's a little too close to the SIO for my liking, but I think it's wonderful he's involved with us as much as he is.
But that sequencing is going to impact
healthcare in
profoundly.
You know, we use the word revolution, and I'm not sure that's too strong necessarily in this case.
Really? That much.
It will be a fundamental change in the way we conduct fundamental research. As a sort of a geneticist is my background, that the new word is genomicist. And, the difference is a different way of thinking, that people who grew up the way I did with genetics thought of single genes and how a mutation or a defect in a single gene would affect the clinical disorder. Right. Now we're able to think about whatever number it turns out to be, whether it's 50,000 or 100,000, and interrogate them and look at them at one time. These chips that are available now to ask questions about thousands of genes at one time are going to have a profound impact on the way we think about human disease. We'll be able...
How we treat it?
How we treat it. We may be a little bit fanciful, but possibly not. When you're born, a drop of blood might be taken, in which all 100,000 genes were interrogated. And you and I are much more alike than we are dissimilar, but the places where we differ in the genome influence our likelihood to develop things like diabetes or high blood pressure or common disorders. We're probably going to be in a position to predict in the future who's likely to get certain things.
And then to develop therapies to address that.
Right. That, I think, you know, interventions with diet, interventions with exercise, with lifestyle. The pre-patient will be here.
Of course.
And that'll change our educational program dramatically.
And that'll affect pharmacology then, too, presumably.
That's right. So where we got started on this is that we'll prescribe medications in the future, very likely based on what your genetic makeup is. That
I see, of course.
You know, now it's
pretty broadband.
It's a hit and miss. Drugs work very effectively today. We've had tremendous success. But we don't know who's going to respond, who's not going to respond, who's going to have an adverse reaction. We'd like to believe in the future we can influence that and prescribe much more effectively, individualize our medical therapy. And that's what this new School of Pharmacy, I think, in close alliance with the School of Medicine and the rest of the biologists on this campus.
And the chemists,
and the chemist is, we've had conversations, for example, with some of the big pharmaceutical companies as well as biotechnology companies that have a very strong interest in the School of Pharmacy being present here because they see it as an opportunity, starting with this clean slate, to have, to train not only pharmacists, but pharmaceutical scientists.
Oh, of course.
Right. And so we see our mission to be a broad one and to be...
Broader than just a clinical one.
Absolutely. The new school will have relatively few departments, and we'll try and bring into it people from departments across the entire campus. Like you said, chemists, engineers, biologists, maybe even a physician.
Why not?
Why not? And so that's, I think, it's terribly exciting.
That's going to happen soon.
That's been approved.
2001, 2002?
We will probably start construction on the final decision will be made in June as to what the building's going to look like. The first class will matriculate in the fall of 2002. So it's really coming down the pike.
Absolutely.
We've broken ground on another new facility here, a functional magnetic resonance imaging, a very fancy word for a set of magnets that allow us to do imaging in patients as well as animal models of human disease.
Non-intrusive.
Non-intrusive, non-invasive altogether. UCSD will catapult into one of the 3 national centers, probably the largest center west of the Mississippi, capable of doing this type of work. It's being done in collaboration with the Salk Institute, with our colleagues at the VA hospital here on campus. It's a true interdisciplinary activity.
Is it primarily brain imaging or full body imaging? Or?
Start is brain imaging. We have, as you know, and I suspect most people here, we at UCSD and across the Mesa are the #1 neurosciences program in the country. We're quite fortunate to have extraordinary strength here. And I think it makes good sense since we can do this type of imaging of the brain to use it. But we anticipate the heart, other organs will be studied with this going forward. But another exciting part of this to me is, again, this multidisciplinary aspect. We have the San Diego supercomputer.
Right.
We have a bioengineering program here, which is one of the very best in the whole country.
Yep. Yep.
They were very successful under Bob Kahn's leadership in getting one of these Whitaker Awards, which
Yes.
will allow them to establish a new building in bioengineering. Great opportunity for us in the medical sciences to collaborate with the people there in engineering.
Yes.
And then the Cal IT Squared
Right.
initiative, which UCSD was very fortunate to get under Larry Smarr's direction. The imaging is probably going to be a focal point for what comes out of something like the Cal IT Squared. How do you apply advanced information technologies to endpoints like imaging,
Right.
which we do as well as anybody in
Yes.
the country, if not better than anyone else.
And I assume that the information technology also will apply to genomics and lots of other things.
Absolutely. You're absolutely.
Right.
This whole area of bioinformatics.
Bioinformatics, so again, a place that we're probably going to become pretty central to.
We're pretty darn good right now, but with the San Diego supercomputer,
Yes.
Cal IT Squared, School of Pharmacy, School of Medicine, SIO, and others, that
It's a pretty powerful combination.
It is. In fact, we had a great conversation, Bob Kahn and I, the Dean of Engineering, a few weeks back. We're anxious to expand our MD, PhD programs here. Educationally, I think UCSD is very well positioned to be a leader in creating the academic physicians for the future. And so we talked about what if we were to envision putting together an MD, PhD in bioinformatics? We would almost certainly be the best in the country.
We have everything here you need.
We do. Just the special resources, the faculty.
Yes.
We could attract individuals.
Supercomputer.
Right.
The Sid Cairns, the Larry Smarrs, I mean, the people who...
Exactly. That would be a super opportunity for us, and I think would help to transform us as an institution.
But also would have a big impact on medical education in general, because those folk, then, the products of such a program, would become very important in other research centers.
You're absolutely right. In fact, the whole area of informatics, I'm probably crossing into your territory here a
No, I'm a
bit.
geometer, so that's all right.
But the computational biology, the quantitative skills that are needed today for healthcare, when we think of bioinformatics, we sometimes think of the very basic aspects of structures of molecules and aligning sequences, but another component of that is advanced technology for medical records.
Oh, of course, sure.
Big challenge for us right now is how do we get that information, how do we process it, how do we make it available for medical research and healthcare.
Right. Accessible to the right people, not accessible to the wrong people, or whoever the wrong people may be. Right.
Well, it's a very big issue for us nationally right now. We must protect the patient's privacy with these medical records, but at the same time, we don't want to...
we don't want to lose the data.
We don't want to impede medical care.
Of course.
And
data is essential.
Data is essential. We can be a leader in this area with the array of expertise we have in mathematics, computer sciences, health services research.
Cryptography, the whole...
Exactly.
This, at some point, I think in the university, we are inclined to take it for granted that education, the teaching function and the research function are absolutely intertwined. But in fact, I think it's also useful to reiterate that, to iterate that, that in fact, what we're doing is also training physicians.
Well, I'm glad you said that.
This is essential to that.
Yeah. It's in the rest of the university, probably the teaching and the research go obviously hand in hand. In our case, there's the third leg of the stool, if you will, which is clinical care.
Of course.
And the ability to deliver the clinical care that the citizens of San Diego and the wider community want require this educational and this research mission be linked tightly together.
In order that the clinical care become the kind that you want.
It's a synergistic situation.
Yes, absolutely. No question.
We use an expression that we sit on a three-legged stool, and the three legs have to be balanced, that if we don't have strong clinical programs, we can't meet our education or our clinical research mission. And they all go
if you don't have a strong research program, the educational program is also going to suffer, and the clinical program will suffer.
And it's worth, I think, at least pointing out that UCSD's role in this community from a healthcare delivery point of view is a very important one.
Yes.
We are located at multiple sites, 2 major sites at Hillcrest and at Thornton. it gives us an opportunity to serve a wide spectrum of the community. It gives us access to individuals with a wide range of disorders, all of which are important for our teaching and our research mission.
Yep. We now also have this agreement now with Children's Hospital, so that we actually have a third place where we're going to be engaged.
We're that close.
Aren't we? Okay. Let's hope it happens.
Well, it's been a long engagement.
Yes, it has been. Right.
And we've had discussions as recently as just yesterday that I'm extremely optimistic this is going to happen. It's very important. It's really important.
Yes, absolutely.
I think it's important most of all for the children of San Diego, because the quality of care for these kids, I think, will be substantially improved by linking our two institutions together.
So again, it's UCSD out in the community.
UCSD in the community, and this is one of those complementary things where 1 + 1 is going to be greater too.
Right, more than 2. Yeah, I think that there's no question about that.
Big issue for us.
Big issue. It's an exciting time. In 10 years, UCSD will be 50, which is early adolescence as far as universities go.
Right.
School of Medicine won't be quite that old, but all right.
Right.
10 years from now, you'll have been dean for about 10 years. Where do you see the School of Medicine? Where do you see any of these issues, medical education, in that time?
Well, you've just described 3 dean half-lives in 10 years, at least deans of schools of medicine. I came here 3 months ago because I think the potential for UCSD is nothing short of remarkable. We are poised.
I think that's been pretty obvious in this conversation.
Yeah, I really do believe we are poised to do some remarkable things here from an educational, from a research and a patient care point of view. If I could revert to Duke University for a second, they like to use basketball metaphors there.
I wonder why. That's an interesting thought. Yes.
They talk about going to the Final Four, and I met the head coach at Duke when I was there, and he said that going to the Final Four is not the thing you want to do. You want to play on Monday night. You want to be in the...
Of course.
I want to go to the Final Four and play on Monday night.
All right.
And I think UCSD has the potential to be... UC's not our competition. The nation's our competition.
Right.
And it's just a wonderful time for us with the community we're in, the support we have here, the biology across the mesa.
Right.
It's just a wonderful,
Strengths
wonderful
on the campus.
Yes. And the growth on the campus.
Yes. Oh, yes. No question. Yes.
Is going to be
and the resources of the state of California.
Knock on wood that the economy...
Knock on wood. It's an incredible engine.
It
really
is.
Yes. And very supportive of the University of California.
You know, we would like to be in the health sciences as much as is reasonable integrated with the entire campus.
Of course.
Our future is tied to UCSD's future.
Of course. And as I said, I think that's a long tradition in this school of
medicine. It is.
Very much
More
so than other schools.
I think you're right.
Schools of medicine. It's had varying manifestations over over 40 years, but I think that the idea of an interlocking has worked pretty well.
Right.
And it's a pretty exciting 10-year prospect. I hope that, in fact, you and I both could have a conversation exactly like this 10 years from now.
I would look forward
when we could say, well, let's see, how did we really do? Are we playing on Monday night?
I'd look forward to it.
I look forward to it. I want to thank my guest today, Dr. Edward Holmes of the UCSD School of Medicine. I want to thank him for a very engaging and optimistic conversation. Mary, back to you.
Thank you, Pat. Next on UCSD Conversations, Scripps Institution of Oceanography graduate student Danny Glavin discusses the search for evidence of life on Mars.
Exobiology is, by definition, the study of how life evolved here and originated on the Earth, as well as possibly elsewhere. Other planets in our solar system, such as Mars, could have potentially had life at one point, or even still today. And also outside of our solar system, looking for planets on other stars and potential for life there. When you're looking for life, what kind of things do you look for? Well, you have to remember what the requirements for life are again. Life as we know it here on Earth. And one thing would be water. So you'd want to go to a place where either there is liquid water or there was liquid water in the past. You could look for fossils. Fossils are a good indication that indeed you had either life before and it's extinct and formed a fossil. But more importantly, in addition, you need to have some sort of chemical evidence that life was once there. when life dies, it leaves degradation products, and you can search for these. So you'd want to search for some sort of organic carbon. Amino acids, for example, would be a good biomarker to look for in the search for life. Amino acids are the building blocks of proteins and enzymes in life on Earth. Proteins and enzymes are important because they catalyze virtually all of the biochemical reactions in our bodies. So they're a fundamental component of the biochemistry. So the question is, if you find amino acids, for example, on another planet, how would you be able to determine whether or not that meant life or not? And that's actually a difficult question. Finding amino acids in their own right doesn't necessarily tell you that you have life. First of all, you need to determine if the amino acid is biological or not, and therefore could be a degradation product of life. The next important question is, does the amino acid have handedness? Amino acids come in two flavors. You have left-handed and right-handed amino acids. Now, all life on Earth is based on the left-handed amino acid. And if you went to Mars, for example, and you found right-handed amino acids, you could rule out the possibility that you had terrestrial L-amino acid contamination, and therefore be pretty confident that life evolved separately on Mars with a unique right-handed handedness. I think that meteorites are a good medium for studying the search for life because they are extraterrestrial. They don't come from Earth. We have at least 10 Martian meteorites here known to be of Martian origin. So by looking at these Martian meteorites, we could potentially say something about whether or not they have amino acids, and these amino acids come from Mars, and that means life. One interesting story is the Nakhla Martian meteorite, which was blasted off the surface of Mars about 11 million years ago by a huge impact event. And pieces of Mars were sent flying into space, and one of these pieces landed on the Earth in Egypt near the Nile Delta. After the meteorites fell, many of them buried themselves within 10 to 30 centimeters inside the Nile Delta sediment. And many of the locals went out and collected samples within a day of the fall. It wasn't until Dr. Hume of the Geological Survey of Egypt visited the site almost 20 days later and collected about 40 stones of the meteorite, totaling about 90 pounds of sample. And these samples were acquired by the Natural History Museum in London, and then one of these samples was recently made available to us for analysis. The sample that we got from the meteorite was first cut in half, and then a piece from the interior was extracted from the meteorite, and that's what we analyzed. And the hope is that it wouldn't be subjected to the terrestrial contamination from the exterior by analyzing a sample in the interior of the rock. I actually have a sample with me. This, in this glass vial here, is a piece of Mars, a crushed sample of the Nakhla Martian meteorite. You can see there's not much there. You know, the rocks themselves are about the size of your fist, maybe the size of a potato, but we only get small, sugar cube size pieces of the meteorite for analyses. Now, we did the analyses of the Nakhla Martian meteorite for amino acids, and we actually found a very interesting distribution of amino acids in this stone. And we essentially get a neat graph showing the peaks of the amino acids. And what we found was a wide variety of amino acids in this rock. Many of them looked bacterial in origin. And at first, we were kind of surprised because we hadn't seen anything like this. It wasn't until we analyzed the Nile Delta sediment for amino acids that we realized we were seeing the same amino acids in this Martian meteorite that we saw in the Nile Delta sediment. You could essentially overlay the two, and it's really a fingerprint of the amino acids that you see in the Nile Delta in Nakhla. So immediately, the problem of terrestrial contamination arises, and we believe that after this meteorite fell into the Nile Delta sediment, it was rapidly contaminated by terrestrial amino acids. They kind of make their way through cracks and liquid. The rocks essentially absorb amino acids from the surrounding environment. The implication of finding what we believe are terrestrial amino acids in the Martian meteorite Nakhla suggests that we're not going to learn very much from Martian meteorites, at least for the amino acid standpoint, because the contamination is so extensive in these rocks. We can't say that this D amino acid is from Mars, this one from the Earth. It makes it very difficult to decide which is which. So I believe we really need to go to Mars and do some of the similar experiments right on the surface and essentially rule out any terrestrial contamination problems. I think that will be the only way we can really get to the root of whether or not life ever originated on Mars. The Mars Organic Detector, MOD for short, is an instrument that we've been developing here at Scripps in collaboration with the NASA Jet Propulsion Lab to do amino acid analyses in situ right on the surface of Mars. I've brought with me a plastic model of the instrument itself. You can see it's small. It can fit right in the palm of your hand and weighs on the order of 2 pounds. And what this sample will allow you to do is take samples from a scoop on a lander or a drill, and it will drop them in this rock crusher here, crush the rocks into a fine powder, and then they'll be dropped into this sublimation heater zone. This heater heats the sample to high temperatures, up to 800 degrees Celsius. This flash heating episode will pyrolyze or vaporize the amino acids into a gas, which will then condense on this cold detector region here. This region's cooled to Mars ambient temperature, which is very cold, on the order of minus 100 degrees C. Once the amino acids have condensed here, we can then detect them by fluorescence. And I want to point out that this instrument is merely a yes or no detector. It tells you, yes, we have amino acids, or no, we don't. Now, this instrument was originally selected for the Mars 2003 lander mission. This was going to be a very exciting mission, very complex. It was going to not only analyze samples right on the surface, but return samples back to the Earth. And MOD was going to be an integral part of that. MOD was going to be used to red flag Martian samples. So if we found samples on Mars that had amino acids, we'd want to make sure we could bring those back and do a more detailed workup of the material to see if it meant life. Now, unfortunately, there have been a couple recent failures in the Mars program, and this has pushed back the sample return mission and the MOD, Mars Organic Detector mission. And we're optimistic that in 2007, we'll have a chance to fly this instrument. Now, the failures on the good side have given us an opportunity to make improvements to MOD. So it won't be just a yes or no detector now. We've added a capillary electrophoresis chip, which will allow us to identify specific amino acids, and more importantly, we'll be able to do chirality. So we'll be able to say something about the handedness. Do we have left-handed amino acids? Do we have right-handed amino acids? And what does that mean for the possibility of life on Mars? This apparatus is called the sublimation apparatus, and it's the laboratory benchtop version of the Mars Organic Detector, which will be flown to Mars. Now, in these experiments, what we do is we pull down a vacuum on the inside of the apparatus to the Martian ambient pressure. Then we add liquid nitrogen to a cold finger in order to cool the cold finger to Martian ambient temperature, which is on the order of minus 100 degrees Celsius. You can see the liquid nitrogen kind of boiling over the top here, and this whole area gets real cold real fast. Once the cold finger is cold, which doesn't take long, we then put the entire apparatus in the oven here and heat it at 450 degrees C for several minutes. Right away, as the sample heats up, the amino acids will vaporize into a gas and then condense right on the tip of the cold finger here where the liquid nitrogen is. Once we're confident that the amino acids have condensed on the edge of the cold finger, we can then analyze the cold finger using high-performance liquid chromatography and see if we find anything. This is a typical result here, HPLC chromatogram showing the different amino acids that have come off the Mars soil simulant. And this process will be the exact process that takes place using the Mars Organic Detector right on the surface of Mars. And we hope that we see some result like this, where we can say we've got amino acids. That'd be amazing. So we'll see what happens. We won't know until 2007. Finding life on another planet would be one of the most important scientific discoveries of all time, bar none. But what you have to remember is that extraordinary claims require extraordinary evidence. And it's not just going to be one experiment which proves there's life on another planet. And it's going to be a combined set of experiments from many different laboratories, all coming to the same conclusion that, yes, this could mean life. For me, the fun part isn't doing the experiments. I mean, that's extremely stressful. I mean, you're analyzing a sample that's, you know, from Mars. I mean, the last thing you want to do is drop it and the glass vial breaks, and I remember having nightmares about doing this kind of stuff. The fun part is once you've got the results in, you feel comfortable with your interpretation, and you get to present your results at conferences and talk to other scientists. For me, that's the best part of the job. I would like to be the first astrobiologist to, for example, go to Mars even. I know that's 20 years, maybe even more down the road, but you know, I'd be in my 40s, still young enough probably to do it, and to be able to search for life right on the surface would be an incredible experience.
Finally tonight, we'll meet Fred Cutler, the new director of UCSD CONNECT, talking with UCSD TV's Shannon Bradley.
This is Fred Cutler, a former teacher, marketing executive, and entrepreneur who has come to CONNECT as its second director in 15 years. UCSD founded CONNECT to boost the local technology industries by bringing together people with ideas, expertise, and money. It's now Cutler's job to move CONNECT forward with the plan he calls CONNECT 2.0.
A part of it focuses on what's really driving the high technology growth in the San Diego region. And the San Diego region is not unusual, but there's three specific engines for that growth as it relates to high technology. Telecommunications is certainly one area, and that would include wireless and network infrastructure and all that's needed to be done there to increase the capabilities of the net to bring broadband to every home in America, and a great deal of growth going on in those particular fields right here in San Diego. So there's a set of programs that we're going to be implementing as it relates to telecommunications. The second is, of course, biotechnology, and that area is really exploding now here in San Diego, and there are a specific set of programs that we're proceeding with in that area. And then the third area is the software and the internet area per se, and that has been, as we all know, very hot last year and the year before, but there's very specific areas within that category that are very exciting, and a lot of growth is happening in San Diego in that category. So CONNECT 2.0 is really our decision to address those three particular segments with some specialized programs from CONNECT to lend very specific assistance to those entrepreneurs choosing to start or grow a telecommunications-oriented company, a biotech-oriented company, or a software and internet company. And we're doing that through a set of partnerships with the San Diego Telecom Council, Biocom San Diego, and the San Diego Software and Internet Council.
Well, how do you do that? What are these partnerships?
Well, specifically, I'd like to point to our Springboard program. It's been so successful over the years. It's been copied all over the world. It really isn't rocket science, Shannon, but the focus of the Springboard program is to lend very early assistance to those entrepreneurs who have that glimmer of an idea for, let's say, a new biotechnology-oriented company. And what we do is bring in what we refer to as a Springboard panel, made up of experts in that particular field that these entrepreneurs are considering moving into. So you'd like to bring in the best possible business expertise, market expertise, and technology expertise, bring them into this Springboard panel, as we refer to it, so that we can provide the very best early assistance to those entrepreneurs. And in our case, from the CONNECT point of view, the assistance is as much mentoring and coaching and helping them along the way, rather than saying, no, this is not a fundable idea, go away. We're here to help them look for ways to make it a fundable idea, finish up the business plan, and so forth. These partnerships will allow us to bring in very specific expertise from the area of biotechnology, let's say, much more than we were able to in the past.
And what's in it for the panelists? Why would they contribute their resources and their talent, their time?
I think, first of all, the really astute chief executives realize the value of having early access to technology. So they will come into the Springboard panels and be exposed to new technologies that they may not have been familiar with before, or it's a set of entrepreneurs that are looking at the technology in quite a different, unique, creative way. Smart CEOs realize the business benefit of getting exposed to that view of the technology. Second, and straightforwardly, it's access to talent. When you sit into these Springboard panels, you get exposed to the best entrepreneurial talent that there is in Southern California. And if the startup proceeds, then you see that talent growing that way. But the honest truth is that probably only 1 out of 10 really do proceed, but the talent may be great, and that talent may be useful in doing another startup, or that talent may be interested in joining a larger company here in San Diego. So access to the talent. Third, and I think very importantly from a business point of view, Shannon, is you have early potential access to a strategic partner. This is a small company that may be getting started. You as a CEO of a larger company can view that small company on day one as a potential strategic partner. And in the rough world of the business environment, you may choose to have a strategic partnership with that little startup instead of the competition. So there's a little blocking opportunity that's going on there. And I think the fourth one that oftentimes comes up, and I've been in these Springboard panels and I've seen it happen, it's the interaction amongst the panel members. You could call it networking if you will, but you'll see the top CEOs, the top chief technology people in that field, all in that room, analyzing this new business opportunity, and there's great connections in networking and peer-to-peer relations.
So they're making friends.
They're making friends. And, you know, when the day is done, that's what the business world is all about.
And how do you select the people who will be given this advice and this mentoring? How does someone take advantage of that?
It's an excellent question, because a part of what we must do is to say no to a fair number of people who come to us with ideas. But, you know, first and foremost is, are the entrepreneurs coachable? There's a good basic idea there, but we're in the business of helping to move it to a real viable business opportunity. That means the entrepreneurs must be able to listen and to be coachable and to learn from the advice of others.
Those interested in getting help from Connect should go online to connect.org.
You merely fill out the application and you state a bit of detail about what your idea is and who you and maybe your entrepreneurial partner, your backgrounds, and that merely gets submitted to us online, and then that goes through our fairly quick review process. It takes about 2 weeks, and then we'll set up some initial review meetings just to sit down and talk to you and your entrepreneurial partner and flush out a little bit more detail as to what you're really looking for. The other alternative is just to call us up on the phone, and we'll fax you the application, and you fill that out and send it back if you'd like to do that, other than doing it online.
The other part of Connect, too, is a partnership with the university. Could you tell me about that?
You bet. It's a great new direction for Connect. It's part of this new Connect 2.0 set of programs. But we have been so successful in the past, Shannon, in assisting entrepreneurs, high-tech entrepreneurs, in doing their thing. As you know, our new theme line, or our new tagline, is where entrepreneurs come for results. And we really take that very seriously. We see Connect as a place where entrepreneurs can come for assistance so that they can get results. And that is more and more important today as the economic situation out there really does get a little bit tighter than it was in the past. But what we're doing now with these other programs around Connect 2.0 is taking that basic strength that we have within Connect and now applying it within the university campus. And specifically, Connect is partnering with initially the Jacobs School of Engineering to assist the technology commercialization of new research in science coming out of initially the Jacobs School. We'll also, under a lot of discussions with Dr. Holmes, the new dean at the School of Medicine, as well as the San Diego Supercomputer Center. And the common theme there is lending assistance to the commercialization of the science, of the intellectual property that is coming out of those great areas of the campus. So in particular, a key component of this Connect 2.0, what's next for Connect, is we're setting up a new Connect office inside, initially, the Jacobs School of Engineering, so that the research scientists can come to us over there in the Jacobs School and basically come in and say, I've got this great technology that I've created from perhaps a government grant. What should I do now? Does it have any commercial viability? What should happen with that technology?
Well, as you know, Connect's had a history of making friends more easily with people on the outside of the university than inside, because there's some resistance by some of the market coming into the tower, so to speak. So how do you overcome that? How do you make that bridge?
Well, I think there is some, not necessarily clarification, but a clear understanding of what we are choosing to do here, I think really is important. And the point there is that we're really focusing on technology commercialization. That is, how can we benefit the researchers and the university by being more proactive in getting that technology, that intellectual property, used by the outside world, whether it's new science in biotechnology that has the opportunity to save lives, or new science in wireless that can make things a lot more efficient in the business world. The objective there is to make it easier for that technology to be deployed outside. We don't see this as affecting the purity of the science that's being created, the discovery that's happening on campus. What we want to do is to take advantage of that great work and allow the outside world to have access to it. In particular, we think to a large extent the research scientists that are creating this kind of technology will want to stay right on campus, but want to see the benefits of their work being appreciated by the outside world. So we're there to help that.
And you see a change in attitude?
Well, I really do. I think there is, biotechnology is such a perfect area, Shannon, is that there is so much great work that's coming out of this campus that needs to get pushed out quickly to the outside world so that it can benefit society, to get to the bottom line. And I believe, having done that, there can be a financial benefit to the university and to the research scientists by being a bit more proactive on that. And I believe that our ability at Connect to help build real new businesses from scratch, perhaps, around that technology, allows that technology to be more quickly, more readily used outside the campus.
Cutler's had some experience in building a business. In 1994, he co-founded Digital Style, an internet company that became an enormous success.
Well, as I understand it, the business plan that you and your co-founders put together didn't have a whole lot to do with what actually happened.
Of course.
So tell me about that.
That's not unusual either, Shannon. I think that's what we talk a lot with our entrepreneurs about, is that what's really important is how good you are as an entrepreneur, and can you scale, and are you willing to throw your business plan out in 6 months, because that is what happens more times than not. And that certainly happened at Digital Style. Our original plan was to provide a set of software to help people create very high-quality websites. And we were going to do this all on our own, and we were going to get people to buy this particular software package, and off and running they would go. Well, in fact, that didn't work. It ended up being a piece of software that needed to fit in with a lot of other software from other vendors. And then the total package made sense for people who were creating very professional websites. So I wouldn't say we totally threw the plan out, but we threw 90% of it out within 6 months of getting the company funded. And I think, looking back on it, that is what we had to do, and we were ready to make those changes when that time came.
So a company that you had a hand in starting was later sold and became worth over $100 million within 5 years. That's not the norm for most startups, right?
That is correct.
So how do you get people excited to say, hey, something like this could happen to you at Connect?
Well, you know, I think you get people excited by being flexible. you don't want entrepreneurs to focus on, quote unquote, the endpoint, the liquidity event. You want entrepreneurs to focus on, if you do great things, results will come from that. So, you know, you don't want them to focus too much on how much money am I going to make when I go through an IPO, or, you know, if we sell this company, how much is it worth? It isn't that. It's the excitement around doing something great. And if you do something great, as perceived by the marketplace, everything else seems to kind of start falling into place. If you do the reverse as an entrepreneur, I want to sell this company for $100 million, and what do I need to do that? That's really backwards thinking, and you can sometimes end up tripping because you're not focusing on the customer at that point. You're focusing on yourself selling the company for $100 million.
You grew up in Michigan, and somewhere along the way developed a passion for vintage cars. Is that right?
Well, you can't stay away from automobiles too long when you grow up in Detroit. That's true.
Well, tell me about your favorite vintage cars.
Well, I was a professional car racer in the early days, and so my father worked for Chrysler, so I'm an advocate of Chrysler automobiles, and so I love old Chrysler cars, and so we have now just purchased a new old 1940 Woody, an old station wagon, Plymouth, that we'll throw the surfboard in and go down the beach and drive around, so that's going to be a lot of fun. A part of this old car thing is so I can take my old 93-year father out and drive him down on the beach, and so we can always remember my father forever through that car. So this is an important thing for us.
I'd like to turn now to some regional concerns. As you know, San Diego had a terrible recession in the early 90s, and now these industries that you're promoting, biotech, telecom, and software and internet, are they any better able to ride through a recession than defense and aerospace?
Well, I think the real difference now for the San Diego region is that there's multiple cylinders that are firing very well to drive the overall engine for the economy. Whereas in the past, it was much too focused on one thing, defense. So what we have is three cylinders doing very, very well. Software and the internet, in spite of what everybody is saying about the dot-com meltdown and all that, there's some very, very interesting activities going on here in San Diego to extend the capabilities of the internet. So more internet infrastructure deals. But if it was just that alone, we should be concerned in the region. But we've got the software and the internet area. Biotechnology is going to be a definite hot spot, will continue to be a hot spot here in San Diego. And the whole wireless area, the wireless internet, if you will, there are those in San Diego who claim that this is going to be ground zero for this next stage of growth for the net. If it's not going to be ground zero, it's going to be very close to it. So those three things going together, I think, help balance out. Maybe one will soften for a year, another one will expand, and I think the fact that we've got all three firing quite well right now, today, is a real good news for the region.
What about all of those who have investments in the stock market, in these new technologies, and they've seen those portfolios decline?
Right.
How do you encourage them to keep the faith? I mean, what do you tell them when they say, hey, you know, this was worth so much last year and now it's down here. Should I keep investing or should I look elsewhere?
Well, I think the answer to that lies in understanding the basic fundamentals of what's going on with this technology. So an example would be the internet. I think it is not correct to say the internet was a fluke, all investments in the internet are foolish. But if you look at the technology of what really the internet provides, it's really a public network that allows all kinds of things to happen between business partners, between businesses and consumers in a much more efficient way. Because of the internet. That's an irrefutable statement. That won't change. The technology has brought that capability to us. Now the trick is how you can build businesses around that technology that will be profitable. And I think that is where the smart investor has to think through really what the technology brings to the table, and then where are those companies that can really create a profitable business around that. Now, we've learned where a lot of businesses have been started that will not be profitable, so I think a great deal more caution now. But leaving the technology sector would not seem to be the appropriate thing to do, even though it's a lot tougher now than it was a year ago from a pure return on investment point of view of your money.
All right, well, Fred Cutler, thank you for being with us.
Thank you, Shannon.